Okey, kita mula. Assalamualaikum warahmatullahi wabarakatuh dan selamat pagi. Okey, saya akan explain untuk IDP 2 bagi bahagian geoteknik. Okay. So basically saya rasa apa yang awak belajar daripada geoteknik 2 akan digunakan untuk menyelesaikan masalah bagi IDP 2 ini. Okay. So saya difahamkan ada 11 pelajar yang akan discuss on the technical punya issue, okay, and the rest student, okay, we discuss on the other civil engineering, the other civil disciplines, okay. So at least when you attend this session, okay, you will get again, okay, what you have learned on your geotechnic 2. Okay. So ini adalah satu situasi menunjukkan bahawa pentingnya untuk mana-mana civil engineer untuk design for the foundations. Okay. So dia tunjuk gambar apa, dia katakan bahawa satu structure telah dibuat, okay, tapi disebabkan lambat untuk menghantar superstructure tersebut, substructure tersebut, maka dia pun gunakanlah this butter ataupun this bricks untuk cater the load from the this superstructure. Okay. So sebab apa? Sebab this fabrication of steel, okay, most probably they have carried out at the yard, okay. Then they just bring to the site and then assemble in the site, and while waiting for the drawing from the substructure, so they just lay all this superstructure on the top of the bricks. Okay. So looks like it is very important for us, okay, to design for the substructure. Okay. So but we need to get the correct informations, okay, in order to design for the substructure. Okay. So saya ada pengalaman lah untuk design for substructure, okay, either using a deep ataupun shallow foundations. Okay. So what information that we need to gain before we can do the design, okay. So the most thing is to get the value for the capacity of the soil itself, okay. So we call as a bearing capacity. So for the bearing capacity, actually we get from the SPT value, or we can estimate by using the soil basic soil properties value. Okay. So for your you need IDP ni, kita bagi buat ni. Awak dah rasanya dah di apa? Saya nak tengok. Sebab kat saya dah di share dalam apa, dalam saya nak buang juga. Saya guna satu skrin je lah. Sekejap saya tersalah klik tadi. Okay dah. Okay. Saya nak tanya yang apa, grup IDP 2 untuk geoteknik, okay, ada tak awak dapat information untuk projek awak? Boleh bagi respon tak? Hello?
Doktor. Oh.
Ada dapat tak the information for your IDP 2 untuk geoteknik?
IDP itu tu kita orang punya information sama dengan IDP 1.
Oh, okay.
carry on
Hello?
forward. Maksudnya kita carry on lah forward information tu.
Okay. So awak clear lah. Okay. So dah ada all this information. Okay. Presentation. Okay. So you need to come up with the presentation of the soil profile. Okay. So saya akan tunjuklah macam mana untuk prepare for the soil profile. Okay. Then for the soil profile, okay, you need to produce what we call as the allowable bearing capacity for shallow foundations. Okay. So apa yang saya dapat maklumat, at every 0.5 meter up to 3 meter deep for each borehole. Okay, awak dapat berapa borehole? 2 eh? Susahlah kelas online ni. Awak senyap ke cepat? Berapa borehole awak dapat?
Rasanya macam kena buat 3.
3. Tapi information of the borehole dah dapat belum?
Dah, hari tu ada dah bagi apa tu SI report dengan rasanya
Okay.
uh,
So problem yang foundation ataupun building yang nak perlu di construct dah dapat dah?
building, kalau building macam belum kot.
Ialah sebelum awak nak construct untuk shallow foundation, awak mesti tahu apa load kan?
Rasanya
Okay.
yang tu macam belum lagi kot.
Okay, tak apa. Yang ni untuk first class ni saya terang dulu. Nanti kita communicate menggunakan WhatsApp group lah untuk geoteknik. Okay. Janganlah senyap pula. So saya perlu tahu maklumat apa yang awak dah dapat. Nanti saya akan guide untuk complete awak punya assignment ni. Okay. So then, for example, if the shallow foundation, okay, is not able to sustain the load, okay, from the structure, superstructure, at the same time, you need to calculate for the use of the pile foundations. Okay, so either you want use as a start by using single pile. Okay, so then you may continue for the group of pile. Okay, so at the same time, okay, if there is an area of slope, okay, sloping area, so in order to increase the stability of that particular sloping area, so perhaps you can provide a retaining wall. Then at the same time, you need to check for the stability, okay, including the sliding, overturning and bearing capacity. Okay. So basically yang nombor 1, 2, 3 ni awak dah belajar dalam Geoteknik 2. Okay. So untuk nombor 2, 4 ni awak dah belajar untuk Geoteknik 1. Cuma additional of sliding, overturning and bearing capacity ni, okay, iaitu tidak di-explain di dalam Geoteknik 1. So awak kena dapatkan dia punya maklumat lah. Okay. Bukan sekadar awak nak kira dia punya apa nama ni, dia punya the lateral force saja. So awak kena kira the stability of the retaining wall. Okay. So masa saya submit untuk saya punya professional engineer, so saya menggunakan this retaining wall design saja. Okay. Maksudnya sekali juga dengan the reinforced concrete RC bar semua tu yang perlu diletakkan di dalam wall. Tunjuk untuk this IDP. Actually kita punya IDP ni antara IDP yang terbaik lah. Panel EAC. Okay. dia dah jelajah saja dan dia kena IDP TM lah untuk civil. So at the end, kalau awak boleh kumpulkan semua IDP awak dapat maklumat semua IDP awak belajar ni, so basically kalau dalam masa awak kerja, dia memudahkan semasa awak kerja sama ada sebagai consultant ataupun sebagai kontraktor. Okay. Okay. So this is for the there will be a first and final presentation, betul ke? Boleh respon?
Betul.
So bila first presentation?
Presentation dia sekali je, Dok.
Sekali. Oh, tadi kata betul maknanya macam mana? Ada first ataupun final?
Oh, final je, final. Yang first tu poster.
Oh, final.
Yang poster.
Oh, poster. Okay. Okay. So kita ambil yang final lah. Tapi benda sama kot yang saya explain. Okay. So shallow foundation. Okay. For the beside you check for the bearing capacity. Okay. You should also check for the settlement. Okay. So settlement, immediate and consolidation should be checked. Okay. RC design siapa buat? Kalau untuk RC, group structure yang buat ke?
Ya, betul.
Okay. So Geotechnical group kena provide the what we call as the area of the foundation, okay, and also the what we call the location of the foundation in terms of the depth from the surface, from the surface. Okay. So then proposed pile foundations. Okay. So this is some suggestion. Okay, 150 mm dengan 300 mm square precast concrete, single and group. Okay. So then you need to check for the geotechnical structural capacity. So let's say if you want to add an additional punya problem which is related to eccentricity. Okay. So if we gain more better understanding lah. Kalau awak masukkan eccentricity, kalau awak setakat buat straightforward, so basically tiada apa kelebihan ataupun apa knowledge baru yang awak dapat. So when you put some eccentricity problems in your what we call in your design, so at least you have cater for the eccentricity. Okay? Sebab ada keadaan yang mana the load from the column, okay, will not rest at the center of the foundations. Okay, so then for the structural team, you need to design for the pile cap. Okay, okay. So retaining wall, okay. Basically for retaining wall, yeah, for the geotechnical team need to check for the stability, okay, and then come up with the RC design. Okay, okay. So kalau awak cekap yang ini, nanti kalau dah cukup 6 tahun, awak dah praktis, okay, awak boleh apply for PE lah. Okay. So awak dah tahu macam mana nak design untuk this retaining wall. Okay. So awak akan gunakan EC code kan, Euro code kan, EC7 untuk geoteknik, untuk RC EC apa? EC2. Awak pun tak ingat
Untuk RC isi tu.
Kalau RC isi tu.
Awak beli tak buku Saleh?
Beli.
Saya ada tiga version buku dia. So memang saya guna untuk kerja-kerja consultation lah. Okay. So this is for the soft profile. Okay. So tentukan kat mana the location of the borehole. Okay. Then from this borehole, okay, awak tentukan for each layer apa type of material, ataupun type of soil. Okay, so you can group based on their density, okay, and also based on the type of the material. Okay, so definitely yang belakang adalah merupakan the dominant material lah. Okay, so for example for this clay sand, okay, silty sand, then there is a layer of sandy silt and hard sandy silt. Okay, so basically untuk selain pada profile, okay, you need to put in the table, okay, for example the depth, okay, the soil type, okay, and the N value, okay, which is this N value is gained from the SPT, standard penetration test. Okay, this standard penetration test, okay, you can get from the borehole report, okay, or bore log. Okay, so for the N value, okay, actually you can get the Q allowable, okay, or you need to use some relationship, okay, to what we call as to get the soil properties, and then from the soil properties you can get the Q allowable, or you can there will be some equation which is directly can convert from N to Q allowable. Okay. So prepare this kind of table, okay, to explain in a detail informations for the soil conditions. Okay, at the same time, you need to prepare for this kind of diagram. Okay. So letak legend lah, menunjukkan bahawa this is the clay. Okay, it's better kalau you will letak the distance from one borehole to another borehole. Okay. Okay, so this is the equation, okay, yang mana awak boleh gunakan. Okay, for example, if the dominant is a clay material, okay, so you can do you can convert the value of the N, okay, to the unconfined compressive strength. Okay, so later on you may divide into 2, okay, to get the C value. Okay, so if it's a purely clay material, okay, so saya rasa kalau ada maklumat on JKR punya value ataupun Macintosh probe punya value, okay, so you also can use this Macintosh probe punya value untuk determine the bearing capacity as well. Okay, so mana nak dapat, saya rasa kalau ini tak ada, okay, so you can get it from either from any reference book ataupun you can get it from the Google. Okay, so that is for the clay, okay, while this is for the sand. Okay, so if it's dominant as a sand layer, okay, so you can convert from the N value, okay, and get what will be the allowable soil pressure, okay, or you can do some conversion to get the value for the internal friction angle. Okay, so then later on you may convert the internal friction angle into a allowable bearing capacity based from either shallow or based from the what a deep deep foundations. Okay. Kalau ada soalan tanya saya go through this PDF dulu, nanti saya akan pergi pada slide. Okay. So saya rasa awak masih ingat lagi, okay, the part of the putting with the bearing capacity equations, okay. So this is for the based on Terzaghi, okay, and then we have another one based on Meyerhoff. Okay, so awak nak guna mana-mana salah satu, mana-mana pun boleh. Ada nak guna Terzaghi ataupun nak guna Meyerhoff. Okay, this is for the directly loading at the center of the foundations. Okay. So kalau ada issue of eccentricity, okay, so you can use this approach. Okay. So dapatkan dulu bahawa berapa nilai E dia dan pastikan the E dia should be less than B/6 baru boleh guna this kind of approach. Okay. Okay, that is for eccentricity. Okay, then we move to the settlement. Okay, we have two types of settlement. Okay. Either immediate or consolidation settlement. Okay. And then we need to include both of this immediate and consolidation settlement as the total settlement. Okay. So kalau purely purely sand, okay, you just need to calculate for the what we call as for the immediate settlement only. Okay. So for this discussion, I will discuss only on the immediate settlement under the footing under the clay layer. Okay. Sebab kalau untuk sand, you need to use the shamanment approach. Okay. So kalau the foundation resting on the sand layer. Okay. So this is the the equation lah. Okay, untuk dapatkan the settlement. Okay. So make sure that the settlement should less than 25 millimeter. Okay, that is the allowable settlement. Okay, it's more than 20. Ya, walaupun awak dah kira the bearing capacity, tapi when we apply the design load, okay, and then the design load, the settlement from the design load, it exceed 25 millimeter. Okay, so you need to reduce what we call as the load from the foundation, the load on the foundation, or you need to what we call as to enlarge the shared foundation itself. Okay. Sebab apa, kalau lebih 25, walaupun dia boleh cater bearing capacity, dia tidak capai keadaan yang dibenarkan dalam serviceability limit state SLS. Okay. Although it already can cater or can is stable under the ultimate limit state punya condition. Okay. So pastikan yang tu awak tengok nanti kalau waktu present takut benda tu awak tak perasan. Settlement melebihi 25. Okay. Okay, immediate settlement for foundation on saturated clay. Okay, so this is another formula, okay, which is saturated clay maknanya betul-betul keadaan clay tersebut dipenuhi ataupun groundwater level berada dalam keadaan yang hampir dengan surface. Okay. So you can use this diagram or graph, okay, to get the SE value. Okay. Okay, then for consolidation settlement, only apply or applicable for clay layer only. Okay. So you may use this formula, okay, to get the value for the SC. Okay, so the combination between SC and SE is the total settlement. Okay. Okay, ada soalan? Tak ada. Tak ada pun cakap tak ada, ada pun
Tak
cakap ada.
ada.
Senyaplah kelas, susahlah kalau buat dalam online ni. Itu tak suruh, belum suruh buka kamera lagi kan. Saya pun tak buka lah. Sebab awal pagi sangat. Okay. Okay. So then sebenarnya kalau it's better for you to design for the pipe foundation juga. Okay. But you need to try for the shallow foundation first lah. Macam ni lebih banyak information awak dah masukkan dan tepat. So lebih banyaklah markah yang awak boleh dapat. Janganlah awak terus jump to pipe foundation. Okay. Maknanya awak terus kena kira dulu shallow foundation dan pastikan shallow foundation awak tu tak selamat lah. Kalau selamat, awak takkan proceed untuk pile kan. So kalau pile pun pastikan single pun tak selamat, so awak proceed for the group. Kan? Kalau awak buat straightforward pile single dah selamat ataupun dah cukup, nanti discussion awak sikit, tak banyak. Okay? Okay. So this is a learning process kan. Maknanya awak buat saja kesemua assume the condition you may design for the group of file. Okay. So nanti kalau awak kerja janganlah awak pergi pada group of file kalau boleh shallow foundation kan. Okay. So this file foundation, okay, basically, okay, either we can use the soil properties value, for example C and Phi, or we can use directly from the SPT and value. Okay. So sebab apa? Sebab kalau kat site, normally we can gain a lot of data, okay, from the SPT rather than we need to get the undisturbed sample and then submit to the lab and then carry out for the lab testing. Okay. So the information from the lab, okay, is less that we can get compared to the field data. Okay. Tambahan untuk dapatkan undisturbed sample, okay, satu kita kena dapatkan when the SPT is less than 12 or 15. Okay. So kalau SPT more than 15, okay, kita gunakan kaedah lain iaitu Messier punya sampling, okay, which is the SPT range from 10 to 20. Okay, if more than that, so it's very difficult to gain or to obtain the undisturbed sample and to carry out for the laboratory test. Okay. So satu lagi cost, very costly lah untuk kita buat laboratory test. So we can use this empirical formula, okay. From this empirical formula, which is from the SPT, then we can convert into the QU value. Okay. Okay, so this is the QU value for the clay. Okay, and this is the QU value for the silt and sand. Okay. So basically, this is for the what we call as for the end bearing, okay, and this is for the friction. Okay. Sebab tu dia ada istilah average. Okay, maknanya dia ambil average value. Okay. So for the average, you need to group into a suitable group lah. Contoh kan, kalau 9, 10, 9, tiba-tiba jump to 20 kan. Okay. So jangan masukkan 20, just group 9, 10, 9. Kalau 20 mungkin 24, 25, okay, then suddenly 40. Okay. So 20, 24, 25 tu satu group dan 40 pun satu group. Okay. So then get the average. Okay. So AB is the area of pile base, where AS is the contact between pile and soil, which is the perimeter, okay, times the height untuk dapatkan the friction between the soil and the pile. Okay. So from there, from that ultimate load, okay, you need to divide with the factor safety lah. Sama juga dengan yang shallow foundation sebelum ni, okay, need to divide with the factor safety untuk digunakan dalam design load. Okay. So pastikan the factor safety daripada divide dengan factor safety, okay, the allowable load ni should greater than the load from the superstructure lah. Okay. So the load superstructure should less than the allowable load from the substructure. Okay. So this is the QU over FS. So we have here QP, okay, plus the QS. Okay, QP is the end bearing, QS is the friction. Okay. So either you want to use the overall methods, okay, or you may divide into for the FS 1.5 of the FP 3.0. Okay. Untuk pengetahuan semua, yang ini bukan based on EC7 okay. So EC7 saya rasa belum di-implement lagi untuk subjek kita lah. Most probably mungkin next semester kot. Okay. So there will be a little bit different, okay, untuk geotechnical punya design menggunakan EC7. Okay, so this is based on the still on the BS where we just multiply, we just divide with the factor safety. Okay. Okay. So this information, okay, you should put in your presentation as well. Okay. So you need to address what we call as the what is the size of the pile, okay, yang awak nak gunakan. Okay. So buat a table, Excel table. Okay, then masukkanlah the equations. Okay. Nanti saya bagi PDF ni. Tapi sebelum tu saya akan tanya Dr. Kamarudin dia punya ni. Okay. So that is for the apa nama ni, untuk single file. Okay. Then we move to group of file. Okay. So design yang single lah ke group of file daripada shallow, single and group. Saya rasa Geotechnic 2 pun awak buat lebih kurang begini kan. Cuma tak ada masuk sampai element of RC punya design. Okay. So in practice, center to center file spacing is kept to minimum of 2.5. Okay. Sebab apa? Dia ada istilah of efficiency lah. Okay. Maknanya dia efficient, dia bertindak untuk menghasilkan this pressure bulb. Okay. So jika dia terlampau dekat, dia akan overlap dan dia tidak ada overlap, dia tidak efficient enough. Okay. So jika terlampau jauh, dia tidak behave as a group of pile, dia akan behave as a single pile. Okay. So that's why it is suggested the minimum is 2.5. Okay. So the range is between 3 to 3.5 diameter. Okay. Okay, this is how we can estimate the efficiency of the load bearing file, and it should almost near to 1. Okay. Okay, untuk group of file, okay, for check the efficiency, okay, so we need to determine the capacity based on the block, okay, and then estimate the single pile capacity, then multiply the number of the pile. So for example, in this case we have 12, okay, so we need to multiply the capacity for each pile with 12. Okay. Kalau it is the problem is located at the center, so it is a very straightforward punya calculation. Okay. So then, okay, yang ini kalau the issue of it is not located at the center, okay, so we need to calculate, we need to put the effect of the moment, okay, due to the problem is not located at the center of the pile, okay, center of the group of pile. Okay. So it's better for you to come up to this discussion. Okay. At least you can address the issue of the eccentricity. Okay. So then we move to the retaining wall. Okay. Okay. Retaining wall digunakan untuk maximize the area. Okay. For example, okay, contohlah kalau kita nak buat this area, okay, digunakan untuk parking lot, okay, rather than we need to construct a slope, okay, to make it stable, okay. So the it's better to choose of using retaining structure, okay, to cater the load from this slope, okay. Okay. So kalau awak tak design for the retaining structure, so awak perlu ambil beberapa lagi kawasan untuk design slope supaya dia dalam keadaan yang stable. Okay. So basically the reinforcement yang berada di belakang, okay, lebih penting sebab dia untuk support tension, okay, compression dan tension perlu juga diletakkan di sini, okay, semasa design with a minimum diameter of the bar. Okay. So there will be another type of method. Okay. Saya rasa ni apa nama ni, saya tak ingat, lupa nama. Okay. Kita ada apa, creep wall and gabion wall. Okay. So I guess for your case, it's better for you to design for the retaining, this type of RC retaining wall. Okay. So basically untuk design for this RC retaining wall, okay, so you need to determine first what we call as the active lateral pressure. Okay. So this active lateral pressure, okay, will be cater or will be catered by this retaining wall. Okay. So for the retaining wall concept, it rely on the width of the RC wall. Okay. Kita ada satu lagi iaitu embedded wall. Okay. Which is dia ditanam di dalam. Okay. Contoh macam second bopal ataupun sheet pile. Okay. Tapi kalau retaining wall ni dia adalah based on the width of the wall. So the width of the wall is very important. Okay, means that the dimension is very important. Okay. So awak kena tentukan berapa nilai lateral load yang akan dikenakan. Okay, from this lateral load, so you need to come up with your design of your retaining wall. Okay. Okay, so this is the Rankine theory untuk dapatkan the retaining the retaining the lateral earth pressure. Okay. So kalau single, if the soil is single layer, so you can directly use this formula lah. Okay. Kalau multi layer, so saya rasa awak kena buka balik buku Geotechnical 1, okay, untuk tentukan berapa kapasiti ataupun berapa nilai load datang daripada multi layer of soil. Okay. So there will be two ways. Okay. Either you want to use for example a sand layer, okay, as a backfill layer. Ataupun kalau awak rasa awak nak gunakan the soil yang ada, existing soil, okay, so you need to use multi-layer punya soil punya calculation. So untuk memudahkan awak gunalah sand ataupun single layer masuk as a backfill, okay. Then you just use the single layer calculation. Okay. Okay, so kalau slope, kalau this soil on the top of the retaining structure, okay, design or construct as a flat. Okay. Jika ada a sloping on the top of the on the backfield itself, so you need to include or you need to use this equation, okay, which is we include the alpha in the equations. Okay. While that is for the Rankine, okay. So for the column theory, based on the column theory, okay. So we need to include what we call as the delta. Okay. So the delta is the friction between wall and soil, which is less than 2/3, which is less than the phi value. And normally we use 2/3 of the phi. Okay. 2/3 daripada internal friction angle untuk delta. Okay. So the equation based on the column, okay, boleh gunakan yang ini. Okay. The more complicated discussion yang mau buat dan betul dan faham, okay, most probably you will gain more marks during your presentation and reports. Okay. Yang penting awak buat betul dan faham. Okay, that is for the how to get the lateral stress either from Rankine or column. Okay. Then the last one is for you to what we call as to determine the stability. Okay, the stability ada 3. Okay, which is first, this retaining wall, okay, will be rest on the soil, and you need to check the capacity of the soil, okay, in terms of the bearing capacity, okay, and it should greater than the weight or the capacity of the weight of the retaining wall with this additional of soil of the backfill. Okay, so itu adalah satu. Okay, yang kedua, the lateral load, okay, from this backfill, okay, should not greater or should not allow for the overturning. Okay, so dia possible untuk berlaku overturning disebabkan oleh lateral load yang ada. Okay. So you need to make sure that it not allow for this retaining structure to overturn. Okay, itu yang kedua. Yang ketiga, okay, and at the same time, based on this lateral force, okay, should not allow for this retaining wall to slide. Okay. So untuk kurangkan sliding dia, okay, sama ada awak boleh add an additional of passive force, okay, untuk membantu untuk mengurangkan dia berlaku sliding. Okay. So the formula you can get from any textbook lah, okay, untuk mengira berapa nilai what we call as the overturning, the bearing capacity, and also on the sliding. Okay. Okay, boleh? Ada soalan? Hello.
Tak
Sekarang
ada, doktor.
Kita semester depan baru ada apa? Face to face Awak bersedia tak semester depan face to face ni?
Kita orang SEM ni last.
Ialah semester depan saya cakap memanglah saya ni last.
Oh. Tapi
Baik, bersedia
semester
tak?
depan kita orang dah tak ada.
Awak pergi mana?
Kita orang 4 year SEM 2.
Awak ni semester 4. Awak tahun 4.
Semester 8 dan semester yang last.
Oh, bukan awak ambil IDP pada semester pada tahun 3
Tahun 3 tu IDP
IDP 1.
1.
Oh, okay. So buat betul-betul lah IDP ni. Nanti awak kerja, awak boleh terus implement. Contoh, Saya rasa kalau complete IDP ni, awak belajar on apa yang sewerage semua betul tak? Drainage. Ada. Saya pun tak ingat lah IDP macam mana. Sebab saya pun first time balik untuk mengajar IDP ni. Tapi on geoteknik lah. Oh, awak dah habis. Okey lah. Okey. Maknanya dah tahulah, dah buat LI semua kan? Dah cekap lah ni. Okey. So ni pun dengar pun macam dah tahu kan? Buat penat saya explain.
Tak juga.
Belum tahu doktor.
Tapi seronok awak belajar ni sebab saya pun sekarang ni banyak buat kerja-kerja apa macam consultation yang terbaru tengah apa nak design apa reban ayam. Bukan reban ayam yang kecil tu untuk 10 ekor 20 ekor. Ni 40,000 ekor. So kita design untuk reban ayam, so banyak lagi kita belajar kan. Tapi saya part on foundation lah. So belajar bersungguh-sungguh lah. Jadi kalau awak nak jadi ni lah, kalau awak nak jadi engineer lah, kalau nak jual apa kosmetik tak perlu belajar ni. Okay. Ada soalan? Ke nak borak-borak, tak nak borak?
Tak ada soalan, doktor.
Tak ada lagi setakat.
Ada ke? Tak ada Oh, tak ada, macam boleh habis awal lah. Ke nak tambah lagi? Kalau saya pergi on slide kejap, nampak ni.
Nampak doktor.
Tapi benda yang sama je. Ini daripada Prof Azman Kasim, saya pinjam slide dia. Jadi daripada apa Dr. Kamaruddin. So basically sama je. So shallow and deep foundation. Okay. So macam kita kalau boleh kita go for shallow. Okay. Tapi tengok dulu the loading and the capacity of the soil lah. Okay. So nanti kalau awak jadi engineer, contohlah kalau company tu kata kita buat Macintosh probe saja, so awak cubalah cakap at least kena ada juga buat SPT. Okay. Sebab SPT more reliable lah banding dengan Macintosh probe. Okay. Sebab banyak informasi awak dapat. Okay. Lagi banyak informasi awak dapat, lagi cekap apatah lagi awak punya justification lebih tepat. Okay. Okay. So kalau shallow, the ratio between D dengan B is less than 1. So if greater than that, so we consider as a deep. Sebab shallow dia tak boleh tahan lateral load compared to the deep. And okay. So normally kalau untuk shallow ni kita hanya ambil what we call as kedalaman pada the same D lah. The same B. Contoh kalau B dia 1 meter, so the soil profile yang kita patut tahu lebih kurang 1 ke 2 meter saja. Okay. Sebab yang itu yang kita akan gunakan dalam design. Okay. So kalau untuk deep, okay, it's better to design up to the end bearing. Okay. Tetapi kalau terlampau jauh, okay, so it's better to design based on the friction. Okay. So untuk dan perlu mungkin capacity of the number of the pile kena banyak lah. Okay. Dan pastikan the settlement is less than 25 juga. Okay. So ini adalah the equation based on the shallow. Okay, saya tadi pun dah terang kan. Okay. So awak kena faham mana value awak kena gunakan. Okay, for example CNC, QNQ, half gamma B times N gamma. Okay. So where CNC is diambil daripada soil below footing. Okay. While gamma adalah diambil below footing juga. Okay. So kita below the footing and gamma satu lagi, sorry, yang this gamma, okay. Sorry, Q and Q. Okay. Okay, sorry, yang ni. Yang ini diambil pada soil from the top of the surface, the ground surface to the same level of the foundation. Okay. Okay, above the bottom of the footing. Okay. Biasanya maklumat tu tak ada beza sangat lah. As long dia bukan tanah yang tanah yang di replace. Okay. Okay, so this is the discussion untuk what we call the failure mechanism. So this failure mechanism actually proposed by Prender and then by Terzaghi. So awak imagine ni, maknanya Prender dia establish this what we call as failure mechanism since 1921, okay, without using any numerical or any physical testing. So dia gunakan mathematical untuk get this kind of failure mechanism. Okay. 100 tahun yang dulu. Masa saya buat PhD, saya guna small scale laboratory testing. So saya dapat sama dengan Prandtl, okay, dan dapat tentukan the magnitudes accurately, okay, menggunakan laboratory test. Okay. Okay, while for the pile, okay, so yang ni untuk kawasan berhampiran tepi laut. Okay. Tak tahu mana Dr. Azman ambil gambar ni. Okay. So for the pile foundations, okay, we have end bearing, which is laid on the rock formations. Okay. Then we have a friction pile, okay, which is rely on the friction between the soil and the pile, okay, and there will be an additional support by the end bearing juga. Okay. So ini adalah untuk mengira dia punya capacity lah, QU. Okay. So it depends on the type of the pile yang digunakan, sama ada cylindrical pile, hollow lah, maknanya dia ada kosong ni. Okay, then or we use this H pile. Okay. Okay, in terms of load transfer mechanism, okay, the QB is the base, while the QS is the skin friction. Okay. So the QB, it depends. Okay, if it is end bearing, the QB is more greater compared to the QS. Okay. And for the settlement value, okay, if the floating or the friction pile, it greater than the end bearing. Okay. So the okay, if there is a groundwater level, so there will be a significant difference in terms of the calculation. Okay. So awak kena masukkan this groundwater level if between the soil and the footing. So Q ni akan mengalami perubahan. Okay. So kalau dia berada di bawah, yang ini pula akan mengalami perubahan. Yang itu nanti depends on awak punya problem. Nanti dalam awak punya soil layer punya profile tu, dia masukkan juga information on the groundwater. Okay? Sebab dia akan mempengaruhi the density of the soil. Saya lupa nak pesan, yang untuk soil layer tu masuk, soil profile tu masukkan groundwater juga. So this is for the point bearing capacity, okay, which is dah discuss sebelum ni. Okay. Untuk pile rest on the hard layer. Okay. Normally we can consider the what we call as the QS is almost not significant. Okay. Okay, so this is on how we can get the information on the NC, okay, and the NQ to be put in our design. Okay. So for the frictional resistance, okay, so you can use the alpha method. Ada 2-3 approach ataupun formula. Beta, alpha saya tak ingat. Tapi kalau yang common yang biasa kita guna adalah alpha lah. Okay. So ada alpha is the friction between soil and clay. Okay. Kalau untuk sand, kita menggunakan this formula. Kita menggunakan effective stress punya approach. Okay. Dan kena pastikan this effective stress punya approach, okay, kita kena dapatkan the effective length. Okay, normally effective length ditentukan based on 15 times the diameter of the pile. Okay. So kalau awak tak guna 15 times diameter of the pile, you may overestimate the capacity of the friction pile. Okay. Nanti value dia akan terlampau besar, which is not really represent the actual pile capacity. Okay. So normally lepas awak dah design ni, awak kena buat biasa kalau kat site dia akan buat sama ada maintain load test ataupun pile dynamic analysis punya PDA punya test untuk tengok betul tak calculation ataupun betul tak capacity yang boleh ditahan oleh pile. Tapi kita tak masuk dalam chapter ni lah. Okay. Yelah, maksud saya kalau awak overestimate, nanti awak apabila consultant yang untuk test, buat maintain load test tu dapati load yang dia apply ni tak mampu ditanggung, dia akan menyebabkan pile to fail. Okay, so this is the way that we can get the addition factor daripada alpha untuk clay. Okay. So you need to refer to this diagram. So then multiply with the CU later on. Okay. Okay, this is for the sand. Okay, so the sand, this is the formula untuk dapatkan K. Okay. Okay, then in here they stated that okay, this is the value that you may multiply with the phi, okay, which is range between 0.5 to 0.8. Then kita determine what the critical depth. Kita gunakan 15G. Okay. And after the 15G, the effective stress will be constant. Okay. Kalau tak, logically dia akan increase lah. Okay. Tetapi kita tak nak overestimate, so it will be a constant after the 15D for the sand. Okay. And then later on, if a combination of sand and clay, okay, so we need to combine all of the calculation based on the layer of the soil. Okay. Okay. So another way is by using the SPT, okay, value. You can directly get the SPT from the testing, okay, and for the skin friction, okay, so we need to get the average from the top to the pile tip. Okay. Kalau untuk end bearing, so kita kena estimate the friction, the end bearing based on the SPT dengan ambil kira 10D ke atas dan 4D ke bawah. Maksud 10D tu diameter dia kalau kalau diameter 1 meter, maknanya daripada tip sampailah 10 meter, okay, we need to get the value for the SPT, get the average, okay, and then daripada tip sampai ke 4 meter di bawah, get the information, and then get the average between 10D and 4D. Okay. Okay, that is for the sand. That is for sand. Okay, so and this is the what we call for the friction. Okay, this is for the end bearing. Then this is for the friction. Okay. Okay. Then later on, we need to get the design load. Okay. So the design load is the Q allowable. Okay. Either we use the global factor safety or we use the partial factor safety lah. Seperti saya terangkan sebelum ni. Okay. So this is a group of pile. Okay. So benda yang sama saya dah discuss sebelum ni. Okay. Okay. Dia ada dua. Satu, awak kena check the capacity of the pile. The structure capacity itself. And dalam sama awak kena check the bearing capacity lah. Okay. So normally structure capacity lebih besar lah banding dengan the bearing capacity. Okay, kita tak nak ada failure on the structure. Okay. So this FY, this FCU adalah apa? Adalah the concrete and the steel punya apa? Strength. Okay. Your calculation, okay, in the table form, okay, for example like this, okay, to get or to explain, okay, on each layer of the soil punya capacity. Okay, so this is for the settlement. Okay, sebelum ni tak ada settlement calculation untuk pile. Okay, so then you can look on this equation to determine the settlement of the pile. Okay, for a single pan. Okay, so that is the formula. Okay, so basically it is based on the QW. Okay, so from there you may put the value inside the equations. Okay. So this is for single. Okay. Okay. So awak go through lah dia punya this formula untuk dapatkan the settlement. Okay. And for the group of pile, basically sama seperti yang saya terangkan sebelum ni. Okay. So capacity untuk group of pile, calculation dia adalah seperti yang ini. Okay, that is for clay and this is for sand. And settlement of the group of pile, okay, you may use this equation. Okay, so you need to go through and then try to get the value. Okay, and then we may have a further discussion untuk jika awak the problem to get the value for the okay. If it is a floating type, okay, or what we call as the skin friction, so you need to use this approach. Okay. I will not go in detail. Okay. So because untuk geotechnic saja kita akan discuss in detail lah. Okay. Okay, so you need to get the value for the settlement for group of file. For example, for this case, is on the friction type. Okay. Okay, then this is for the group of for the settlement calculations. Okay. Kalau untuk testing, okay, you cannot test on a group of file, you only can test on the single file. Okay. So this is the system. Okay, first they construct the anchor pile, okay, and then they put a beam on the top of the anchor pile, and then they use the hydraulic jack, okay, to apply the loads and make sure that this anchor pile is stronger compared to the test pile lah. Kini menggunakan beam system. Kalau menggunakan maintain load test, this is menggunakan hydraulic jack. So kalau menggunakan maintain load test, dia akan letakkan cartilage, okay, block on the top of the beam untuk apply load. Okay, so for your presentation adalah dalam bentuk begini untuk untuk profile. Pastikan dia punya surface elevation dalam keadaan yang sama tepat, supaya dia menunjukkan bahawa soil surface semua surface tu kan. Okay. So this is example of a design report yang mana awak boleh keluarkan, okay, untuk diproduce dalam awak punya report nanti. Okay. So itu saja. Okay. Nanti saya tanya Prof Hazman dengan Dr. Kamarudin, boleh tak saya share di slide untuk kegunaan grup geoteknik. Okay. Ada soalan? Hello.
Setakat ni belum.
Doktor.
Tak ada Okay, so setakat tu saja kot untuk explanation bagi geoteknik. Okay. So mudah-mudahan manfaat untuk grup geoteknik dan untuk semua grup lah. Okay, kalau ada problem nanti kita akan discuss dalam grup kita, betul tak? Awak prefer macam mana, nak saya follow up setiap minggu ataupun awak nak report kat saya setiap minggu? Macam mana? Ke tak nak dua-dua?
Bergantung
Tahu ada
pada
masalah
doktor kot, mana macam keperluan ke nak setiap minggu update kerja ke, tengoklah macam
bagus
mana.
juga. Setiap minggu awak update. Setiap minggu awak update. At least kalau ikut betul-betul, kalau ikut yang fizikal tu memang setiap minggu ada perjumpaan. Kan dekat bilik atas tu. Di M47 ada studio, IDP studio. Awak last masuk ETM bila? Tahun 1
Sem 3.
Oh, Sem 3. Tahun 2 Sem 3. Sampai hari ni tak masuk ETM dah. Okay lah. Okay. Okay. Assalamualaikum warahmatullahi wabarakatuh and good morning. Okay, bye-bye.
Thank you, Prof.